July 10, 1942. Akutan Island, Alaska Territory. Machinist mate Albert Knack pressed binoculars against his face, peering through the observation blister of the PBY Catalina as it banked low over the marsh below. The overcast sky filtered pale light across the tundra, and there, half submerged in wet grass and bog, lay something that made his breath catch. An aircraft, upside down, wings intact, and unmistakable red circles painted on the wingtips. "Lieutenant Thies," Knack called forward through the intercom, his voice tight with urgency. "There's a plane down there. It's got meatballs on the wings." Lieutenant William Thies adjusted the Catalina's course, descending for a closer look. The patrol plane had been lost in fog banks for hours, navigating by dead reckoning through the treacherous Aleutian weather. When they'd finally spotted the Shumajin Islands at dawn, Thies had chosen the most direct route back to Dutch Harbour, a path rarely flown, directly over Akutan Island. Now, circling 3 times to mark the exact position on his chart, neither man fully grasped what lay in that marsh below. A Mitsubishi A6M Zero, the fighter aircraft that had terrorized Allied forces across the Pacific for 7 months. The weapon that had shredded American air power at Pearl Harbor, decimated British squadrons over Ceylon, and achieved kill ratios that defied belief. An aircraft so feared that official American doctrine when encountering one was brutally simple: run away. What Thies and Knack had stumbled upon would later be described by historians as a prize almost beyond value to the United States, not because of what the aircraft could do, but because of what it revealed about what it could not do. The Zero's reputation had been built on a foundation that seemed unshakable: speed, maneuverability, range. But hidden beneath its elegant lines was a design philosophy so alien to Western military thinking that when American engineers finally examined this aircraft, they would struggle to comprehend the calculations that had created it. The discovery would expose the most profound paradox in fighter design of World War II, a paradox written not in performance specifications, but in the lives of the men who flew these machines and the choices made years before the war began. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Zero's dominance had begun long before Pearl Harbor. In September 1940, when the aircraft first entered combat over China, it achieved results that seemed impossible for a carrier-based fighter. Flying from land bases in support of Japanese operations, Zeros encountered Soviet-built Polikarpov I, 15 and I-16, fighters flown by Chinese pilots. The engagements were one-sided. In early encounters, Zeros achieved kill ratios as high as 12-1. The aircraft that American pilots would face possessed capabilities that exceeded every assumption about what carrier fighters could achieve. Maximum speed of approximately 330 miles per hour. Service ceiling above 30,000 feet. Combat radius exceeding 400 miles when carrying drop tanks. And maneuverability that allowed it to turn inside any Allied fighter then in service. On April 5, 1942, the Zero's reputation reached its apex. 36 Zeros from the carrier air groups attacked Colombo Harbor in Ceylon. They encountered approximately 60 British aircraft defending the naval base. Hawker Hurricanes, the fighters that had helped win the Battle of Britain. Fairey Swordfish, torpedo bombers. Fairey Fulmar fighters. Against this force, the Zeros achieved devastating results. 27 British aircraft were shot down. The Japanese lost 1 Zero. The mathematics were inescapable. Allied pilots facing Zeros were dying at rates that made conventional air combat doctrine suicidal. American fighter pilots received explicit orders that reflected this grim reality. Do not attempt to dogfight with Zeros. Do not try to turn with them. If engaged, use speed and diving power to break contact. Survival, not victory, was the objective. By June 1942, when Japan launched its campaign to seize Midway Atoll and establish positions in the Aleutian Islands, the Zero's mystique had solidified into something approaching fear. American pilots who had survived encounters with the aircraft reported capabilities that seemed to defy physics. It could outturn, outclimb, and outlast any American fighter. It appeared invincible. The pilot who would inadvertently change this calculation was 19 years old. Flight Petty Officer Tadayoshi Koga launched from the Japanese carrier Ryujo on June 4, 1942, as part of the second wave attacking Dutch Harbour. His Zero, serial number 4593, was assigned to strafe American positions on Amaknak Island. Koga and his wingmen, Chief Petty Officer Makoto Endo and Petty Officer Tsuguo Shikada, dove on the harbour with practiced precision. They shot down a PBY-5A Catalina flying boat. Koga strafed survivors in the water as they struggled in the frigid Aleutian Sea. The attack was devastating and professional, but during one of his low passes, small arms fire from American positions on the ground found his aircraft. A single bullet. It struck the oil return line from the engine, not immediately catastrophic. The engine continued running, but precious oil began streaming from the damaged line, misting into the cold Aleutian air. Within minutes, the engine would seize. Koga had perhaps 10 minutes of flight time remaining. 25 miles east of Dutch Harbour sat Akutan Island. Japanese planners had designated it as an emergency landing field. A submarine waited offshore specifically to rescue downed pilots. As Koga's oil pressure dropped, he signalled his wingmen and turned toward the island. From above, the site looked perfect. A broad, flat valley floor, half a mile inland from Broadbight. Green grass, stretching smooth and inviting, solid ground for an emergency landing. Shikada, circling overhead, suddenly noticed something that filled him with dread. Water. Glistening between the grass stalks. The ground was not firm grassland. It was a marsh, boggy tundra that would trap any aircraft attempting to land with wheels down. He tried desperately to signal Koga. Make a belly landing, wheels up, slide across the surface. But Koga had already committed. His landing gear was down. His approach speed had bled off. There was no time to correct. The Zero's main wheels touched the grass and immediately plunged into soft mud beneath. The aircraft pitched forward violently. It flipped end over end, tossing water and chunks of earth. The Zero came to rest inverted, wings and fuselage nearly intact, canopy buried in the bog. Inside the cockpit, Tadayoshi Koga died instantly. His neck broke from the tremendous impact. He was 19 years old. He had flown combat missions over China and the Aleutians. He had survived the most dangerous profession in modern warfare. He died in a marsh on an island whose name he probably never learned, killed not by enemy fire but by terrain that looked safe from the air. Endo and Shikada circled the wreckage, torn by conflicting imperatives. Every Japanese pilot carried explicit orders. Any Zero that crashed in enemy territory must be destroyed. The aircraft's capabilities were too valuable. Its design is too advanced. American forces must never capture an intact Zero. But Koga might still be alive. They could not see into the inverted cockpit from the air. They could not confirm his death. How could they strafe their friend, their wingman, the pilot who had flown beside them for months? The decision paralyzed them. They circled again, lower, straining to see any movement from the cockpit. Nothing. Just the Zero resting, upside down in the marsh, wings gleaming wetly, engine silent. Fuel was running low. The weather was closing in. The submarine assigned to rescue operations would search for Koga. If he had survived, the submarine would retrieve him. If he had not, the submarine would destroy the aircraft to prevent capture. Endo and Shikada turned west toward the Ryujo, believing they had done what duty allowed. They could not know that the USS Williamson, an American destroyer patrolling the area, would drive the submarine away before it could complete its mission. They did not know that Koga's body would remain in the cockpit for more than a month. They could not know that their decision to leave the Zero intact would help alter the course of the Pacific War. The Zero sat undisturbed through the remainder of June. Fog concealed it. Rain battered it. The harsh Aleutian climate tested every component, but the aircraft remained essentially intact, invisible from standard flight paths, unknown to American forces. The marsh that had killed Koga also protected his aircraft from discovery. Ships passing offshore could not see into the inland valley. Patrol planes following established routes flew over water or along coastlines, avoiding the turbulent air over Akutan's rugged terrain. July passed. The Zero remained hidden. Japanese intelligence assumed the aircraft had been destroyed or had sunk too deeply in the marsh for recovery. American forces, focused on the battles at Midway and Guadalcanal, knew nothing of the prize waiting in the Aleutian fog. Then, on July 10th, Lieutenant William Thies made a navigational decision that would prove momentous. Lost in fog during an overnight patrol, his PBY Catalina had drifted far east of its intended course. When dawn broke and the clouds lifted enough for celestial navigation, his navigator calculated they were approximately 250 miles off course. Thies chose the most direct route back to Dutch Harbour, over Akutan Island. Albert Knack, serving as plane captain and observer, had been in the gun blister stretching his legs after the long patrol. He had been interested in Akutan for months. The island hosted an old whaling station from the sailing ship era. The entire island had been converted to a silver fox farm, with the animals running free to be trapped for their pelts. On clear days, Knack would search the valleys with binoculars, watching for wildlife. That morning, July 10th, the cloud cover was high enough to see deep into the valleys. Knack was scanning with his binoculars when he spotted something light-coloured against the dark tundra. An aircraft, upside down, with red circles on the wings. The discovery set off a chain of events that moved with remarkable speed. Thies returned to Dutch Harbour and immediately briefed his commanding officer, Commander Paul Foley. A salvage team was organised within hours. The next day, July 11th, Thies led the team back to Akutan. They approached the Zero cautiously, weapons ready, uncertain what they would find. Navy photographer Arthur Baumann accompanied the team, documenting everything. They waded through the marsh to the inverted aircraft. The Zero was remarkably intact. The fuselage showed minimal damage. The wings were bent but not broken. The engine appeared undamaged. One man peered into the cockpit and found Tadayoshi Koga still strapped in the pilot's seat, his body preserved by the cold Aleutian climate. Albert Knack, the smallest member of the crew, crawled into the inverted cockpit and cut Koga's safety harness. They extracted his body with as much dignity as circumstances allowed. Whatever their nation's conflict, Koga was a warrior who deserved respect. They buried him in a shallow grave nearby, marking the site carefully. Then they turned their attention to the aircraft. Even inverted and damaged, the Zero possessed an almost predatory elegance. Sleek lines, minimal protrusions, a design that whispered speed and maneuverability. But as they examined the structure closely, something began to trouble them. The aircraft felt light, not just light for its size, but light in a way that seemed wrong. Chief Aviation Pilot William Scarborough, an experienced Navy pilot assigned to the recovery team, tapped the fuselage with his knuckles. The sound that came back reminded him of tapping a tin can. Hollow, fragile, not what he expected from a combat aircraft. He examined the cockpit area, searching for armor plating. American fighters mounted thick steel plates behind the pilot's seat. Protection against attacks from behind, the most common combat angle. He found nothing. No armor plate, no protective backing, just a thin metal frame with a fabric cushion. He inspected the windscreen. American fighters increasingly used armored glass, heavy transparent plates that could stop small arms fire. The Zero's windscreen was standard glass, perhaps slightly thicker than civilian aircraft, but offering no ballistic protection whatsoever. He checked the fuel tanks. American aircraft used self-sealing tanks, multiple layers of rubber compound that swelled when punctured, closing holes and preventing fuel leakage. These tanks were heavy but saved lives. A bullet through a self-sealing tank meant a manageable leak. A bullet through an unprotected tank meant fire and death. The Zero's fuel tanks were simple aluminum containers, thin-walled, unprotected, no rubber sealant, no self-sealing capability. Nothing but thin metal between thousands of pounds of high-octane aviation fuel and enemy bullets. Scarborough stood in the Aleutian marsh, looking at the inverted Zero, and realized he was seeing something that contradicted everything American aircraft designers believed. This aircraft had been designed with fundamentally different priorities. Performance had been purchased at the price of protection. Speed and range had been bought with the lives of the men who flew these machines. The recovery team, photographed the Zero from every angle. They documented every detail before attempting to move it. They measured components. They examined construction techniques. They noted the complete absence of protective features that American designers considered mandatory. The recovery attempts would prove challenging. On July 12th, Lieutenant Robert Kermser led a second team to the site. They gave Koga a proper Christian burial, replacing the hasty grave from the previous day. Then they attempted to recover the aircraft. But the delivery ship lost 2 anchors in the rough conditions. Without heavy equipment, they could not free the Zero from the marsh. The attempt was abandoned. Finally, on July 15th, a third recovery team reached Akutan with proper equipment. They constructed a sledge to drag the Zero through the marsh to the beach. Even waterlogged and mud-covered, the aircraft was remarkably light. 6 men could maneuver it. This lightness, which had seemed advantageous during recovery, would prove to be evidence of the fundamental design choice that made the Zero both formidable and fatally vulnerable. The Zero was loaded onto a barge and transported to Dutch Harbour. There it was, turned right side up and cleaned. Then it was loaded aboard the USS Street Michiel for transport to Seattle. The journey took the better part of a month. The Zero arrived in Seattle on August 1st. During that transit, American intelligence officers pored over the photographs taken on Akutan. They debated what they had captured. Was this typical of all Zeros? Were the missing protection systems due to combat damage or weight reduction? Had they discovered a variant, or was this standard construction? From Seattle, the Zero traveled by barge to Naval Air Station North Island near San Diego, California. There it was placed under a 24-hour military police guard, not primarily to prevent sabotage, though that was a concern. The guards were there to prevent souvenir hunters. Every mechanic, every pilot, every engineer wanted a fragment of the legendary fighter. The guards had orders to shoot anyone attempting unauthorized access. Navy mechanics began meticulous repair work. These were experienced aircraft technicians who had worked on fighters from multiple nations. Propaganda had prepared them to find a crude imitation of Western designs, built with inferior materials and sloppy workmanship. The myth of Japanese industrial inferiority was widespread in 1942. What they found instead shocked them completely. The Zero was a masterpiece of weight reduction engineering. Every component had been designed with obsessive attention to minimizing mass. The main wing spars were constructed from extra super duralumin, a lightweight aluminum alloy developed by Sumitomo Metal Industries in 1936. This material combined zinc with aluminum to create an alloy lighter and stronger than standard aircraft aluminum. The Japanese had countered its tendency toward corrosion with zinc chromate coating applied after fabrication. This was sophisticated metallurgy equal to or ahead of American capabilities. The structural components revealed ingenious weight-saving measures. Wings were permanently bonded to the fuselage, eliminating the massive removable joints that American designs used. This reduced weight but made major repairs nearly impossible. The aft fuselage detached just behind the cockpit for maintenance while keeping forward structure minimal. Engine placement near the wing's leading edge allowed a shorter, lighter tail section while maintaining proper balance. Control surfaces used fabric covering, where American designs employed heavier metal. Landing gear struts were narrower than American equivalents, adequate for the lighter aircraft but more prone to failure. The cockpit framework was minimalist, offering excellent pilot visibility at the cost of any protection whatsoever. As repairs progressed, detailed measurements revealed the full picture. The A6M Zero weighed 5,555 pounds fully loaded. The Grumman F4 Wildcat, America's primary carrier fighter at that time, weighed 7,426 pounds. The Zero was 1,871 pounds lighter, nearly 2,000 pounds of difference. That weight gap translated directly into performance. The Zero's Nakajima Sakai 14-cylinder radial engine produced 950 horsepower. The Wildcat's Pratt & Whitney R 1,830 twin Wasp generated 1,200 horsepower. The American fighter had 250 more horsepower, but carried 2,000 more pounds. Power-to-weight ratio favored the Zero decisively. Wing loading told the same story. The Zero carried 24.3 pounds per square foot of wing area. The Wildcat carried 28.6 pounds per square foot. Lower wing loading meant the Zero could turn tighter, climb faster, and maneuver more aggressively. In a turning dogfight, physics gave the Zero an insurmountable advantage. But the fuel system troubled every mechanic who examined it. The tanks were simple aluminum containers, thin-walled, completely unprotected. American self-sealing tanks used multiple layers. An outer layer of vulcanized rubber, a middle layer of fabric, an inner layer that swelled when fuel made contact through punctures, closing holes and preventing leakage. These tanks were heavy and expensive. They reduced fuel capacity, but they saved lives. A bullet through a standard tank meant ignition, fire, death. A bullet through a self-sealing tank meant a small leak, manageable, survivable. The Zero had chosen differently. Every Japanese pilot flying this aircraft flew knowing that a single bullet in the fuel system meant probable death. There would be no gradual fuel loss, no chance to nurse a damaged aircraft home. There would be ignition, explosion, catastrophic fire. American pilots had reported Zeros bursting into flames from minimal damage. Intelligence officers had debated whether this was exaggeration or propaganda. Now, examining the unprotected fuel tanks, the reports made terrible sense. The Zeros were not exploding because of some weakness in Japanese fuel or some flaw in construction. They were exploding because that was what happened when bullets struck unprotected aluminum fuel tanks filled with high-octane aviation gasoline. The lack of pilot armor was equally disturbing. Every American fighter mounted thick steel plates behind the pilot's seat. These plates added substantial weight, but statistics proved their value. Pilots flying fighters without armor died from rear attacks at far higher rates than pilots in protected aircraft. The armor was not complete protection, but it dramatically improved survival odds. The Zero pilot sat in a thin metal frame with a fabric cushion. A .50 caliber machine gun bullet would pass through the seat and the pilot with equal ease. There was no protection from behind, no protection from the sides. The windscreen offered no ballistic protection from head-on attacks. September 20th, 1942, 2 months after the crash on Akutan Island. Lieutenant Commander Eddie Sanders climbed into the cockpit of the repaired Zero for its first test flight. Sanders was one of the Navy's most experienced test pilots. His assessments would determine tactics for every American fighter pilot in the Pacific. He settled into the lightweight seat, noting immediately how cramped the cockpit felt compared to American fighters. The instrument panel was laid out efficiently but with less redundancy than American designs preferred. The engine started smoothly. Japanese engineering, whatever its other qualities, produced reliable power plants. Sanders taxied carefully. The narrow track landing gear made ground handling tricky. The Zero wanted to weather vane in crosswinds. He advanced the throttle and felt the aircraft accelerate with surprising eagerness. The takeoff roll was remarkably short. The Zero lifted off and climbed with an immediacy that startled him, even though he had expected high performance. At altitude, Sanders began systematic testing, level flight, gentle turns, climbs and descents. The controls felt light, almost sensitive. Small stick movements produced immediate aircraft response. After years flying American fighters that required firm control inputs, the Zero felt like switching from a truck to a sports car. He pushed the test envelope further. Maximum speed runs revealed the Zero could reach approximately 330 miles per hour, faster than the Wildcat, but not dramatically so. The performance advantage was real but not overwhelming in straight-line speed. Then he attempted a hard roll at cruise speed. The ailerons, the control surfaces that produced roll, suddenly stiffened. Above 200 knots indicated airspeed. Rolling maneuvers became sluggish, requiring excessive force on the control stick. Sanders tried rolling left, then right. The aircraft rolled to the left much easier than to the right. This asymmetry would be crucial tactical information. In a dogfight, a Zero pilot would naturally prefer left rolls. Knowing this, an American pilot could exploit the tendency, forcing the Zero into right rolls, where it was slower and less responsive. The information could save lives. The next test was potentially lethal. Sanders put the Zero into a dive, building up speed. Then he pushed the stick forward hard, generating negative acceleration, negative G-forces, the kind of maneuver a pilot might use to escape a pursuer by diving away aggressively. The engine coughed, sputtered, and quit. Silence, except for wind streaming past the canopy. Sanders was flying a glider at 3,000 feet over the California coast. He maintained composure, leveled out, and the engine restarted. He repeated the test twice more with identical results. The Zero's float type, carburetor, which relied on gravity-fed fuel delivery, could not handle negative G-forces. Under negative acceleration, fuel flow to the engine stopped completely. Every time. Reliably. Predictably. This was the answer American pilots needed. When being pursued by a Zero, do not turn. Do not try to outmaneuver it in the horizontal plane where it excels. Instead, push the stick forward hard. Dive with negative G-force. The American aircraft, with its pressure-type carburetor, would continue running. The Zero's engine would quit instantly. In those crucial seconds of silence, as the Zero pilot struggled to restart his engine, an American pilot could open range and escape, or reverse the engagement, climbing back to attack the now vulnerable Zero from above. Sanders flew 24 test flights between September 20th and October 15th. Each flight revealed new details. The Zero's famous maneuverability was real, but came with limitations. At low speeds, below 200 miles per hour, it could turn inside any Allied fighter. Its light wing loading and powerful ailerons at slow speeds made it virtually untouchable in slow-speed turning fights. But at high speeds, above 250 miles per hour, the aircraft became stiff and sluggish. The aileron forces increased dramatically. The roll rate decreased. American fighters, heavier and more powerful, gained advantages as speed increased. The heavier American aircraft had higher wing loading, which was disadvantageous at low speeds but advantageous at high speeds where structural strength and power mattered more than agility. The test data was compiled into technical reports distributed to every fighter squadron in the Pacific. Pilots read with intense interest about the enemy aircraft that had haunted their nightmares for 8 months. The reports confirmed what some experienced pilots had begun to suspect through hard-won combat experience. The Zero could be beaten. Not by fighting its fight, but by imposing a different type of combat. Commander John Thatch had already developed his famous Thatch-Weave maneuver before the Akutan Zero was recovered, first using it in combat at Midway on June 4, 1942, the same day Koga crashed. Working from intelligence reports about the Zero's capabilities gleaned from combat encounters and pilot debriefings, Thatch devised a defensive tactic where 2 Wildcats flying side by side would weave toward each other when attacked, bringing pursuing Zeros into the other plane's gun sights. But the captured Zero validated and expanded his theories in ways that pure combat experience could not. The test flights provided precise data on the Zero's limitations. The aileron stiffening above 200 knots, the engine cut under negative G, the asymmetric roll performance. These were not theories or observations from chaotic combat. These were measured, repeatable facts that could be taught to every pilot before they ever faced a Zero. American pilots learned to fight Zeros using what became known as boom and zoom tactics, gain altitude advantage through superior climbing power at high speeds. Dive at maximum speed toward the target. Make a single firing pass using superior firepower. Continue diving past the target, using the American fighter's better diving speed and structural strength. Use that speed advantage to zoom back to altitude. Repeat. Never get slow. Never try to turn with a Zero at low speeds. Never allow the engagement to devolve into a turning fight where the Zero's advantages would be decisive. Use American advantages in diving speed, structural strength at high speeds, superior firepower, and pilot protection to dictate the terms of combat. The captured Zero was flown against every American fighter type in mock combat. Test pilots pitted it against Wildcats, P-38 Lightnings, P-40 Warhawks, and later against Hellcats and Corsairs as those aircraft entered service. Each engagement was filmed and analyzed, frame by frame. Pilots learned firsthand how to exploit the Zero's weaknesses. The films were distributed to training squadrons. New pilots arriving in the Pacific had already seen footage of Zeros in combat. They had studied the aircraft's performance envelope. They understood its strengths and limitations before their first combat mission. The knowledge eliminated much of the fear that had paralyzed earlier American pilots. But the most important revelation was psychological. The Zero was not invincible. It was an excellent aircraft, brilliantly designed for specific missions and specific combat conditions. But it had vulnerabilities. Real, exploitable, tactically significant vulnerabilities. It could be defeated by pilots who understood how to fight it. American pilots who had felt outclassed and helpless now had answers. They had tactics based on engineering analysis rather than desperate improvisation. They had hope grounded in physics and aerodynamics rather than wishful thinking. Lieutenant Commander Eddie Sanders wrote in his formal report, "These flights covered performance tests, such as we do on planes undergoing Navy tests. The very first flight exposed weaknesses of the Zero which our pilots could exploit with proper tactics. Immediately apparent was the fact that the ailerons froze up at speeds above 200 knots, so that rolling maneuvers at those speeds were slow and required much force on the control stick. The knowledge spread through the fleet like electricity. Fighter squadrons modified their training programs. New pilots learned boom and zoom tactics before they ever faced a Zero in combat. Veterans shared the intelligence with relief and vindication. Their earlier losses had not been meaningless. The sacrifices of those early battles had bought time for this knowledge to reach them. Marine pilot Lieutenant Colonel Kenneth Walsh, who would be credited with 21 confirmed kills and awarded the Medal of Honor, later stated that knowing what to do with a Zero on his tail, information that came from Koga's Zero, saved his life several times. Walsh's tactical knowledge derived from the captured aircraft enabled him to survive encounters that would have been fatal under earlier doctrine. Fighter ace Captain Joseph Foss, who would retire with 26 confirmed victories and receive the Medal of Honor, credited the Akutan Zero with providing the tactical framework that allowed Marine pilots at Guadalcanal to fight Zeros on more equal terms. The information reached squadrons at Henderson Field by October 1942, just as the air battle over Guadalcanal reached its peak intensity. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Akutan Zero's influence extended beyond tactics into aircraft design itself. Grumman had already begun work on the F-6F Hellcat to replace the Wildcat. The Hellcat's design had been partially influenced by intelligence reports from pilots who fought Zeros at Coral Sea and Midway. Early specifications called for increased speed, better climb rate, and improved high-altitude performance compared to the Wildcat. The first production F-6F-3 made its first flight on October 3, 1942, just weeks after Sanders began testing the Akutan Zero. But the captured Zero provided hard data to validate design choices and inform modifications during the Hellcat's development. Engineers at Grumman could compare actual Zero performance against their new fighter's projected capabilities. The Hellcat that entered service in January 1943 incorporated lessons learned from understanding the Zero's strengths and weaknesses. It was faster, with a maximum speed of 380 miles per hour. It had a rate of climb that matched or exceeded the Zero at most altitudes. Critically, it retained comprehensive armor protection and self-sealing fuel tanks, but was designed to fight Zeros on more favorable terms than the Wildcat could manage. The Hellcat was designed to excel at high-speed combat, where the Zero struggled. Its powerful Pratt & Whitney R2800 double-wasp engine produced 2,000 horsepower, more than double the Zero's output. This power enabled the boom and zoom tactics that the Akutan Zero had validated, allowing Hellcat pilots to dictate engagement terms rather than responding to Zero advantages. The F-4U Corsair, entering widespread service in 1943, followed similar design principles: exceptional speed approaching 450 miles per hour, powerful armament with 650 caliber machine guns, comprehensive pilot protection, and critically, performance optimized for high-speed combat rather than low-speed dogfighting. Japanese military strategists learned of the Zero's capture through intelligence reports in late 1942. The news caused consternation at the highest levels of the Imperial Navy. They understood immediately what it meant. American forces now possessed detailed knowledge of the Zero's capabilities and limitations. The psychological advantage of the seemingly invincible Zero would evaporate. American tactics would evolve to exploit every weakness. Japanese designers attempted to address the Zero's vulnerabilities in later variants. The A6M model, introduced in 1943, included a 55mm armored glass windscreen and an 8mm armor plate behind the pilot's seat. These additions acknowledged that pilot protection had become necessary as American firepower and tactics improved, but the modifications created new problems. Weight increased 28% compared to the original A6M. The Nakajima Sake engine remained limited to approximately 1,100 horsepower, an increase of only 16%. The later Zeros were slower and less maneuverable than the A6M that Koga had flown. They had lost their primary advantage without gaining compensating strengths. Japanese engineers had tried to adopt the American protection philosophy, but they lacked the powerful engines needed to maintain performance with added weight. The result was a fighter that was inferior to both the original unprotected Zero and the American fighters it faced. The A6M could not turn as well as the A6M. It could not match the speed of the Hellcat or Corsair. It offered minimal protection that was inadequate against 50-caliber machine guns. By 1944, American fighter pilots dominated Pacific skies. The Great Marianas Turkey Shoot in June 1944 demonstrated the complete reversal of air superiority. During the Battle of the Philippine Sea, American fighters and anti-aircraft guns shot down over 600 Japanese aircraft across multiple engagements. Zeros, once the masters of Pacific air combat, fell in staggering numbers to Hellcats and Corsairs, flown by well-trained pilots, using tactics derived from studying the Akutan Zero. American losses during the Philippine Sea engagements included approximately 130 aircraft, most lost to operational accidents during night carrier landings and fuel exhaustion rather than combat. The kill ratio had reversed completely from the early war period, where Zeros once achieved 12-to-1 or higher ratios against Allied fighters. American pilots now achieved similar ratios against Zeros. The quality gap widened month by month. Experienced Japanese pilots who had dominated the early war were being systematically killed in aircraft that could not protect them. Japan's training pipeline could not replace them fast enough. Replacement pilots had dramatically less training, less experience, and less chance of survival. Many Japanese pilots arriving at combat units in 1944 had fewer than 100 hours of flight time. American pilots typically had 300 hours or more before entering combat. In October 1944, during the Battle for Leyte Gulf and the Philippines campaign, Zeros began to be used in kamikaze attacks. When aircraft could no longer compete in conventional air combat, they became guided missiles. Pilots were ordered to crash their aircraft directly into American ships, using the Zero as a weapon delivery system rather than a fighter aircraft. The Kamikaze Corps used A6M fighters more than any other aircraft type for these suicide missions. The Zero, designed to dominate dogfights over China and achieve air superiority across the Pacific, ended its operational career as a disposable weapon. The design philosophy that created the Zero had been based on assumptions that proved catastrophically wrong. Japanese planners in the late 1930s believed the coming war would be short and decisive. They planned to strike quickly, defeat the Americans and British before their industrial capacity could be fully mobilized, and negotiate a favorable peace from a position of strength. In a short war, pilot attrition rates would not matter significantly. Aircraft losses could be sustained for 6 months or a year. Long-term survival rates would be irrelevant because the war would end before attrition became decisive. They also believed implicitly that Japanese pilots were inherently superior. Intensive training, warrior spirit, and tactical excellence would compensate for any material disadvantages. The spiritual strength of Japanese aviators would overcome crude American industrial might. Quality would triumph over quantity. Both assumptions failed catastrophically. The war was not short. It lasted nearly 4 years of brutal, grinding attrition from December 1941 through August 1945. American industrial capacity, once fully mobilized, produced aircraft and trained pilots at rates that Japan could never match. By 1943, American factories were producing fighters in numbers that made Japanese production look insignificant. American pilots, initially less experienced than their Japanese counterparts, learned quickly. Combat experience accumulated. Tactics evolved. Training improved dramatically as lessons from the Pacific were incorporated into stateside training programs. By 1943, American pilots were equal to Japanese pilots in skill. By 1944, with veteran Japanese pilots dead and inexperienced replacements facing combat, Americans held a decisive skill advantage. The Zero's lack of protection, acceptable in a short war, became catastrophic in a prolonged war of attrition. A pilot in a protected American fighter might survive being shot down once, twice, even multiple times. Self-sealing fuel tanks prevented fires. Armor stopped bullets that would otherwise be fatal. The pilot would bail out, be rescued by submarine or flying boat, and return to combat. Each survival meant accumulated experience, improved skills, better tactical judgment. A Zero pilot shot down once was likely dead. The unprotected fuel tanks meant fire and explosion. No self-sealing to slow fuel leakage. No fire suppression systems. No second chances. Every Zero shot down meant one experienced pilot lost forever. The experience gap widened inexorably as American pilots accumulated combat hours, while Japanese pilots died in their first or second missions. In May 1937, the Imperial Japanese Navy issued specifications for a new carrier fighter. The requirements were extraordinarily demanding. Maximum speed of 310 miles per hour at 13,120 feet altitude. Climb to 9,840 feet in 3 minutes 30 seconds. Armament of 2 20mm cannons and 2 7.7mm machine guns. Full radio and direction-finding equipment. And, critically, range sufficient to escort bombers over the vast Pacific distances that Japanese strategic planning required. Meeting those requirements with available engine technology seemed impossible. Nakajima Aircraft Company, one of Japan's premier aviation manufacturers, concluded the specifications could not be met simultaneously. They withdrew from the competition. Only Mitsubishi remained, with chief designer Jiro Horikoshi accepting the challenge. Horikoshi's solution was radical and uncompromising. Make the aircraft as light as possible. Eliminate everything not absolutely essential to meeting the specified requirements. Armor protection was not mentioned in the Navy's requirements. Self-sealing tanks were not specified. Therefore, they were omitted. Weight saved could be invested in fuel capacity, enabling the required range. Lightweight construction enabled the required maneuverability and climb performance. The decision reflected Japanese military doctrine that prioritized offensive capability above all else. Attack was emphasized. Defense was secondary. A warrior accepted risk as inevitable and sought maximum effectiveness in delivering offensive power. Survival was less important than striking the enemy effectively. Horikoshi later wrote, "Instead of pondering the future of the aircraft, our immediate goal was to win the contract." The statement reveals the mindset that created the Zero. The focus was on meeting specifications, winning approval, delivering performance. Long-term consequences of design choices were secondary to immediate capability. The captured Akutan Zero exposed this philosophical divide to American analysis with perfect clarity. United States Navy technical reports noted explicitly that the Zero was designed purely for the attack role, emphasizing long-range, maneuverability, and firepower at the complete expense of protection for its pilot. American designers had made fundamentally different choices based on different priorities and different assumptions about warfare. Protection was not a weakness in American doctrine. Survival was, not cowardice. A pilot who lived to fight again was demonstrably more valuable than one who died in a single engagement, no matter how effective that single engagement might be. The mathematics were unambiguous. trained pilots were more difficult to replace than aircraft. The industrial implications were equally profound. An armored, protected aircraft was more expensive to build. It required more materials and took longer to manufacture. But it lasted longer in combat, and critically, its pilot lasted longer. Japan could build aircraft faster than it could train replacement pilots to fly them effectively. America could train pilots faster than Japan could build replacement aircraft. The mathematics of attrition favored the side that protected its people. After the war ended, captured Japanese aircraft designers were interviewed extensively by American technical intelligence teams. Their testimony confirmed what the Akutan Zero had revealed during those repair sessions in San Diego. The lack of armor and self-sealing tanks was not an oversight or a temporary expedient. It was an intentional design choice based on tactical requirements and operational philosophy mandated by the Imperial Navy. Jiro Horikoshi stated in his post-war memoir that armor protection was never mentioned in the initial design requirements issued by the Navy. Weight restrictions meant prioritizing armament, range, and maneuverability. Japanese military doctrine assigned low priority to defensive features. The underlying attitude, shared across the Japanese military, was that protective features were luxuries rather than necessities. Horikoshi wrote, "Only after wholesale attrition of pilots did we finally understand that living to fight another day was more important in modern warfare than achieving maximum performance in a single engagement." The admission came too late. By the time Japanese designers recognized the flaw in their philosophy, thousands of pilots had died in unprotected possessions, aircraft, and the war's outcome had already been determined. American test pilots who flew the Akutan Zero came away with profound respect for Japanese engineering skill, combined with recognition of the design's fundamental vulnerability. Edward Sanders, who conducted the initial test flights, later wrote that the Zero was the finest aircraft he had ever flown at low speeds. Its maneuverability was extraordinary. Its handling was delightful. The controls were perfectly harmonized. But he added that he would never want to take it into actual combat. "One bullet could kill you," he wrote. "The aircraft gave you no protection whatsoever, no second chance, no margin for error. It was a machine that demanded perfection from its pilot because any mistake, any moment of vulnerability, would be instantly fatal." Captain Eric Brown, the Royal Navy's chief test pilot who flew more aircraft types than any other pilot in history, flew a captured Zero after the war. He called it the most maneuverable fighter he had ever flown. He could turn inside any Allied aircraft with ease. But he also noted the complete absence of armor or protected fuel tanks, and called the Zero a death trap for modern combat. "Beautiful to fly," he concluded, "but terrible to fight in." The fate of Tadayoshi Koga became symbolic of the Zero's flawed design philosophy. Koga was an experienced, skilled aviator. He had survived multiple combat missions over China and the Aleutians. He had demonstrated the abilities that made Japanese naval aviators feared across the Pacific. But a single bullet through an oil line meant his death. If his aircraft had been designed with survival in mind, if vital systems had been redundantly protected or armored, he might have made it back to his carrier. He might have fought again. His experience and skill might have been preserved for future battles. Instead, he died in an Alaskan marsh at 19 years old. His sacrifice inadvertently contributed to American victory in ways he could never have imagined. The aircraft he died in became the teacher that trained his enemies. The secrets he never intended to reveal were extracted from the wreckage and used to kill other Japanese pilots. His death and his Zero's capture changed the Pacific War's trajectory in ways that single battles rarely achieve. In February 1945, the Akutan Zero met an undignified end. Commander Richard Grumman was taxiing the Zero at Naval Air Station North Island when a Curtiss SB-2C Helldiver crashed into it during ground operations. The aircraft was damaged beyond repair. It was scrapped shortly thereafter. Its service was complete. But the intelligence it provided lived on in thousands of American pilots who owed their lives to tactics developed from studying Koga's Zero. The Hellcat's design reflected lessons learned from understanding the captured aircraft's strengths and limitations. The boom and zoom tactics that became standard doctrine stemmed directly from test flights over San Diego. The understanding of the Zero's high-speed limitations, its carburetor weakness, its asymmetric roll performance, all came from systematic analysis of the Akutan Zero. The ultimate lesson was not technical but philosophical. Aircraft design reflects cultural values and strategic assumptions. The Zero reflected Japanese values of offensive capability, acceptance of risk, and belief in short, decisive warfare. American fighters reflected values of pilot protection, long-term attrition warfare, and industrial sustainability. In a prolonged war of attrition between industrial powers, the American philosophy proved decisively superior. This did not make American pilots braver or more skilled individually. It made them more likely to survive. Survival meant experience. Experience meant effectiveness. The cycle compounded over time until American air superiority became absolute and unchallengeable. Modern historians studying the Pacific Air War inevitably return to the Akutan Zero as a pivotal turning point. The capture did not change aircraft already in production. It did not directly influence the Hellcat's initial design, which was already well advanced, but it changed American understanding of the enemy at a crucial moment. It revealed vulnerabilities that could be systematically exploited. It provided hope when hope was desperately needed. In July 1942, America was losing the Pacific War. 6 months after Pearl Harbor, American forces were retreating across the Pacific. Zeros dominated the skies. Defeat seemed possible, even likely. The Akutan Zero arrived at precisely the moment when American morale needed validation, when tactical innovation was essential for survival, and when understanding the enemy was critical. Lieutenant Commander Sanders' first test flight report circulated through naval aviation with electric effect. Pilots read and reread the section describing the Zero's engine cutting under negative G-forces. Finally, an answer. Finally, a concrete tactic. Push the stick forward. Dive with negative G. The Zero's engine would quit. Your engine would keep running. You would survive. That single tactical revelation saved hundreds, perhaps thousands of American lives. Marine pilots at Guadalcanal applied for it. Navy pilots at Santa Cruz used it. Army pilots in New Guinea exploited it. They survived encounters they would otherwise have lost. They returned to base to fight again. Their experience accumulated. Their skills improved. Gradually, inexorably, the balance shifted. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.